All right. Hi, everybody. Welcome back. Let's continue with part two with DEF. Maybe that's ambitious. We'll do at least D. Maybe we'll do DEF. Well, D and E. Okay, let's go. Let's go. So part D says the central bank chooses pi and y to maximize its utility function, subject to the economic output function find pi star that maximizes the central bank utility. Okay, so I wrote the utility function here. This is the central bank utility function. So our job will be to maximize y and pi in this function, lambda y minus 1/2 pi squared, subject to the economic growth function, which is up here, y equals yn plus a pi minus expected pi, plus epsilon. When we're attacking an optimization problem like this, we always want to do as few first order conditions as possible. So we look at this and we see that one of the control variables, y, is given as a constraint, and importantly, that constraint is a function of the other control variable. You see? So we can just substitute this right here, and that will make our life easier. We've now eliminated y as a choice variable. We choose pi, and then pi implies our choice of y using this method. So we get lambda times yn plus a pi minus expected pi plus epsilon minus 1/2 pi squared. And now there's no subject to anything. So we're done. We're ready to take a derivative. We don't even need to form a Lagrangian now because there's no constraint. We just directly take the derivative of UCB with respect to pi and set this to 0 to get a maximum. Okay, so let's do it. We have a pi here, and so we'll have to factor the lambda inwards, right? So the lambda is here. So the coefficient on pi is a lambda. So we'll get a lambda. And there's no power or anything here. This is all just multiplicative. So we have lambda yn, that goes to 0 and take the derivative. We have a lambda pi, the pi goes away, we get a lambda, minus expected pi, this is all 0. Epsilon is all 0, okay? And then over here, we have minus 1/2 squared, so the 2 will come down. We get the 2 cancels, and so we just have pi equals 0. And we can call this pi star because this is the optimum value. So solving this, we get that pi star is just equal to a lambda. Okay, and we're done. So, comment on pi star, is it surprising? Okay, so the optimum value of pi is going to be the product of what is A. A is the sensitivity of output or of growth to surprise inflation. And lambda is the degree to which the CB, the central bank, likes growth. So we put these two things together. If the economy is more sensitive to surprise inflation, meaning the central bank has more power over causing growth, then the pi star will be higher. Right? If raising inflation makes more growth, then the optimum inflation will be higher. And it will be higher if the central bank likes growth more. So these are the two factors that go into choosing the optimum rate of inflation. Sort of this makes sense. Like if the central bank believes that the economy can be grown via inflation, and the central bank likes growth, then it should pick more inflation. Now, what is surprising is that this does not equal 0. Okay, maybe a priori we would think inflation is a bad thing, and so the central bank should just choose 0 inflation and be done. But it's not a bad thing, and it's not a bad thing because of this function, because of this term in the function. We wrote down that inflation can cause growth. See, this is positive. So if there's inflation, then the economy can grow, and the bank likes growth. Okay, so that's why it does not choose 0. Okay. There you go. So you could criticize. You could say, well, this function doesn't make sense. Why does inflation cause growth? And then that's a way that you would criticize this model. You would talk about changes or improvements to the model. Okay, for the household's utility is very simple, so we can quickly optimize it. The household has only one decision function. They're going to maximize expected inflation. Expected inflation given minus 1/2 expected inflation minus inflation squared. Okay, so you can see there's one choice variable, there's one thing, we just take a derivative. So we're just going to take partial UHH with respect to the expectation of pi, which the households themselves choose. They choose how much inflation to expect. Yeah, and then, so the 2 is going to come down, we'll get minus, and then, so that's the derivative of the outside. I guess we can do it step by step, just to be very clear. The 2 comes down, we multiply by 1/2, and that's all negative. And then the inside rides along. You get pi minus pi. And then we have to take the derivative of the inside. This is going to be 1, this is going to be 0. So there's a times 1 from the chain rule. So this is going to cancel. So the 2 and the 1/2 cancel. We're going to get minus expected pi minus pi. So we factor, and that equals 0. So we get pi minus expected pi equals 0. And so expected pi equals pi. Expected pi equals pi. Let me check if that cut off. Did that get cut off? It didn't. Wow, I'm doing such a good job. Pat myself on the back. Okay, good. So that's the answer. So the households will set the expected inflation to be pi. Okay. And we could say, we could put a condition here, right? We could say this is subject to, the households know that pi will equal pi star. Yeah. And this goes to F. Why do households set expected pi equals pi? The special word, the magic word that you need to write down for a question like this is rational expectations. Rational expectations. Okay, what that means is the households know, they know 1, the production function, 2, the central bank utility function, you get the touchpad ASMR. And 3, they also know calculus. Okay, this is rational expectations. So that the households are motivated to figure out what's going on because they want to maximize their utility. They know their utility function. They want to know what's going on in the world to make their utility function as good as possible. So they go in to study economics, they study calculus. They come up with this equation and this equation, and then they solve it. And so they say, aha, the central bank is going to choose. They're going to choose this. So I can do my optimization with respect to the optimum choice. And so we end up with a star down here. Okay? So this is the important notion of rational expectations, that agents will not just make random choices, they'll make the best possible choices given their information set. And their information set is all of the public information in the model. So the only thing outside of the information set in this model is epsilon, right? Anything, this is unknown at the time of solving. This is unknown. But this distribution is known. Okay, so the households know, the households and the central bank, they know 0 is mu, and they know that sigma epsilon is a standard deviation, but they don't know the precise value that this epsilon will take. Okay, but all the parties involved know everything else about the model. Okay, so there you go. That's DEF, and in the next video we will continue with H. See you there.